Welcome to our session on cybersecurity at the edge. My name is Harry Forbes. I'm an analyst with ARC Advisory Group, and I will be moderating today's discussion. My background is in utilities and process control and process optimization for manufacturing processes. ARC is an industry analyst company that's really focused on the OT space. Before I introduce our panel, I want to make sure that you can direct questions directly to us using the Q&A button on the side of the screen. So if there's a topic you wish for us to discuss, or if something prompts a question, please do not be shy and feel free to type in your questions in the Q&A, and we will respect that and try to get them to the panelists in the session. Please use the Q&A rather than the chat button. So thank you, and now let's meet our panel. First, Edgard Capdevielle, who is President and CEO of Nozomi Networks, which is a specialist security firm focused on industrial OT and industrial IoT networks and infrastructure. Edgard, welcome, and please, would you briefly introduce yourself and Nozomi, pardon me.
That's right. Thank you. It's a pleasure to be here. Thanks for having me. Edgard Capdevielle, and I am the CEO of Nozomi Networks. We are a leading vendor in industrial and IoT security. We protect customers with a solution that provides operational visibility, intrusion detection, ongoing monitoring to industrial control networks. Our customers are in verticals that include oil and gas, utilities, pharmaceuticals, manufacturing. Anybody with an industrial control network or an IoT network benefits from having our products and solutions in their networks.
Okay, thank you. Our second panelist is Maria Krovatkina, who is a software security engineer with Schlumberger, which is probably the leading global oil services firm. Maria, welcome. And please tell us a bit about yourself and about your work at Schlumberger.
All right, thank you, Harry. Very pleased to be here. So our center, it's called Schlumberger Industrial Internet Center, so we call it SLEEK, and we specialize at developing and integrating industrial IoT solutions for both internal and external customers. And so my background is in network engineering, but currently I work in the SLEEK security team, and we do security for software and networks in industrial IoT. We do design of security, we do hardening, we do threat modeling and automation, and of course we do education and consulting as well. And we've had really good cooperation with ZEDEDA, which we use on some of our products. So we've been working together on improving security and getting it to the levels of industrial IoT. Thank you.
Thank you, Maria. Last but not least, our third panelist is Erik Nordmark, and Erik is a co-founder of ZEDEDA and now serves as their chief architect. Erik, welcome, and please introduce yourself.
Yeah, thank you very much. Pleasure to be here. So I've been active as a technologist in the industry for a long time, and working at different companies on the operating systems, networking sides, hypervisors, lots of different technologies in this place. And I've also have a fair bit of understanding of the security landscape, not necessarily from building pieces of it, but understanding how the whole thing actually fits together and what are the actual threats out there on the real internet, from being active in something called the Internet Engineering Task Force and the Internet Architecture Board, so sort of seeing what happens on the real internet, right, from colleagues in those organizations.
Well, not being a security expert, Erik, thank you very much. When we were preparing for this session, one of your colleagues described security as the 600-pounder, the elephant in the room. And I would say kind of IT and OT take sometimes very different perspectives on security. And maybe I'll ask this question to begin to Maria. As an end user, when you look at the differences between security in the OT space and the IT space, what do you see as the differences in the needs for security in the OT space and especially at the OT edge?
All right, so this is a really good question that I really like, because I'm an industrial IoT, so it's kind of a merge of both, right? But so OT and IT, they had different histories and they had slightly different application. So when we think about OT, they're used in industrial control systems. Many of the systems used to be air-gapped and isolated. So we have this legacy OT devices that were not designed with security in mind, right? And I would say majority of industrial control protocols, they were as well either not designed with security at all, or security, it's not being properly configured in production, because this is how it historically happens. So also the difference, there's a difference in life cycle of devices, because in OT, for example, devices can be used for 10, 15 years and more. It works and nobody wants to touch it, and it's great. In IT, of course, 5 years and we're thinking maybe it's end of life and it's time to replace. So that's very different as well. But since we're kind of talking about the edge here, so I want to talk more about the edge, and IT was present there historically as well, just the use cases were different. So it was more for connecting the users through remote locations or doing, edge computing. So kind of like letting users to get access to applications and resources over either local network or remote network. So networking, it was always part of it, right? Unlike OT systems. But I think the biggest difference in terms of cybersecurity is priorities. So IT, for IT, confidentiality is kind of the top, and then availability and integrity are secondary, so we can kind of sacrifice them a little bit. And for OT, it's the opposite. So safety is the core, so availability and integrity, they're on top, right? And confidentiality could be quite secondary. So there's different history, different use cases that they kind of shaped OT to protect the process, so that that's available and reliable, while IT was more adaptable and agile, a little bit more secure, because we're letting maybe more systems that are dynamic to connect, like laptops and computers, unlike OT devices that don't really move around. And of course, we can say, we can have an hour of outage for our email or some kind of website, but we don't want to have an hour outage on a nuclear plant cooling system, right? So it's very different priorities, right? And when you're asking, in terms of cybersecurity, what are their different needs? If we focus on just OT, to be fair, there's not as much, designed into security, or at least historically was. So there could be some logic implemented, to filter out inputs from the users. There could be, and we always hope as security professionals, is there's some kind of network segmentation properly done with firewalls. It's best practices. We always hope it's there. But other than that, security may be lacking. And OT, they become more attractive to attackers now, and it's also, I think, important that the war, it moves from physical conflict to cybersecurity fights between countries. So in cybersecurity space, OT is one of the ways you can really harm another country or another company. So OT truly need defense, and they need proper defense in depth, right? And even though, even now some of the IT systems are disconnected, but there are more and more attacks possible for air-gapped systems. We think about physical attacks, and we do need, hardware root of trust and physical security, but there may be a little less likely, and that's what business would think. But air-gapped attacks with malicious USB devices, easily. It happens, it's really easy and cheap to make a device on your own like that and plug it in and infect the network. The other problem with OT, and we would think, why don't we just, take IT's experience and take all these awesome security tools and use them in OT world? Well, it's not always possible to use the same tools and practices for OT networks. And of course, a typical example is any kind of active scanning tools that can crash OT devices. But even if we talk about application firewalls, they need to be aware about industrial control protocols, and they need to be smart enough to understand the transactions and filter them. And then of course it would be great to have intrusion detection and prevention systems, but those also need to be smart and they need to be trained on suspicious activity, which it could be very unique to this specific process that happens in an industrial control system. Yeah.
I was going to ask Edgard if he wanted to jump in on this, because a lot of your customers have similar situations, I think, or similar installations. And what do you think about the distinctions, or what do you see in the ICS?
I think, I think Maria is right on target. It's very well described. A lot of the problems are legacy problems, have to do with how industrial control networks have evolved over time. There's an initial expectation that was true for a very long time of isolation by technology. Prior to the adoption of TCP/IP, that was a de facto isolation protection that was available. Today, the number one enemy by far when it comes to industrial control networks is the perception of air gapping. TCP/IP, as we all know, is a protocol that was designed to connect despite all sorts of issues, and now it's the basis for industrial control networks. So the perception that air gapping is realistic is just probably the biggest detriment to cybersecurity in OT. Air gapping can be achieved at any one point in time, but it's not an assumption that can be made, and therefore makes systems really vulnerable. The other assumption, of course, Maria touched on is the nature of endpoints, or the way you define an OT network versus an IT network has to do with the endpoints. If the endpoint is a supercomputer with a full stack operating system that can handle an IT vulnerability scan, then clearly you're talking about an IT network. If you're talking about a specific purpose-oriented CPU, if you can call it a CPU and very specific programmed logic for a particular process, that's not expecting anything other than properly structured TCP/IP packets in the port, then that's an OT network. And the nature of those two is just radically different, which makes a lot of the cybersecurity tools in IT useless in OT.
I'll take a question that came in just now on Q&A, and it was one I kind of had queued up here. Is this, can you talk about? I'm going to do this without mentioning any specific names, of a horror story of a secure air gap network that was compromised. And I certainly think the one that comes to my mind the most is the attack relatively recently, on process safety shutdown systems, where the hardware itself had a hardware key permissive that would prevent any modification of the program with the key in the run position. But of course, they were not left in the run position for any number of reasons, because they needed access, or the engineers felt they needed access to those. I wonder if anybody else has examples of the kind of false, you were just mentioning, kind of the false security that air gapping provides, or people think it provides.
I mean, I think that one thing I can add, it's not it's more of a pure IT system, but the notion that I had somebody explain to me at a previous company that, the way they get in, it's not like they go in through the front door, right? It's more like, they crawl into the basement, and then from there they find a little passage up to the attic, and then, they find the air vent and whatever. The fact that to get in, they might actually jump through, half a dozen or more different vulnerabilities in different pieces of software, right? If you can get into one place, maybe from there you can get a little bit access to something sitting next to it inside the network. So that's why air gap, for it to work, really has to mean there is no cable, right? Or wireless, right? There is zero connectivity. But that's not how people think of it. They think we have a firewall. Well, but the firewall lets some things through, and can you find one hole there to get in, right? And I think the same thing is true with these combined IT and OT systems, that there's a little gap somewhere where you can get in.
Yeah,
firewalls are great the first 5 days when nobody has touched the rules.
Another thing I would say about that is, again, without mentioning names, but some of the more well-known state actor attacks, what I've seen is companies effectively increase the degree of air gapping that they do, and that affects their operations a lot. So it can, if some of the cost figures that I've seen, what did this attack cost you? I think are grossly understated, because there's an operational effect if you're under attack, where your operations are maybe not compromised, but sub-optimized to a great degree on account of this. And the costs can be very high. Anyone else want to jump in on that question? Or otherwise we'll just move on. And the next one I'll kind of send to Erik, and certainly it's related. There's been a number of very widely publicized security breaches in the past several years, and especially involving OT. Can you kind of summarize your view on that, how it happened and what end users should do to prevent them? And again, without mentioning any names or pointing any fingers, I don't think that's what we want to do.
Yeah,
it's really a concern.
So I mean, I think that the ones that have been more publicized are the ones that affect consumer equipment, right? Because they become more visible, right? And I didn't think that there's that much publicized other than the recent pipeline shutdown type things, but where it really bubbles up that people can see that something is broken because it affects the whole sort of large scale infrastructure. But some of the consumer ones, yeah, I mean, it's driven by, these things were designed with default passwords, poor passwords, and one of the things that was sort of very prevalent at the time was this thing that shows another factor. And one of the things that Maria and Edgard brought up was, it's about protecting your IT and OT infrastructure. Well, but it's also protecting the rest of the world, right? In the sense that the Mirai botnet attack that happened, where they managed to install botnets on various consumer, IP cameras and whatever. And then they used it to attack a large part of the internet infrastructure. So they took out Facebook for several hours, just because not by taking out Facebook directly, but by attacking what's known as the DNS infrastructure. And so it's an example of saying, it's not only about, sure, you want to protect yourself, but you also don't want to be a stepping stone for being used as an attack to others. So that shows sort of the complexity of this whole landscape, that there's many facets to it.
And another question that came in that is also kind of related to that and to the previous question. And the question is there a compliance or a legal consequence and accountability when OT gets breached, or is it just headline news? And is anybody want to talk about that? I certainly have an opinion about that, but I'm not a legal expert at all.
Well, let me chime in. I think OT getting breached and the causality of that breach, whether it is negligence or bad operations versus I just happen to be the victim. I mean, let's do an analogy, right? Let's say I have a car accident. Do I have any accountability? The market is really mature. Some people are going to determine whether it was my fault or not, and if it was my fault, then I will pay, and hopefully there are no human damages. But I think we're not that mature yet when it comes to cyber. We do have compliance provided by the likes of NERC, NIST. It traditionally lacked teeth. Of course, over the years, the penalty capability has improved. And then we've seen, obviously, in the 100-day sprint that the current administration is promoting, the increased requirements for protecting critical infrastructure and specifically industrial control networks. Right now, it's more of a carrot, right? The federal government speaking with its wallet, which is more of a carrot than a stick. I think this question is primarily focused on the stick side of the house, and I don't think we have the capability of, and I don't want to call it victim blaming, but determining that the victim is to blame. For example, we happen to know that some of the operators that have been in the news lately on pipelines or otherwise happen to be extremely good cybersecurity operators. And the second thing I would say, if you allow me to maybe expand on that, is the question you asked, Gary, specifically said highly publicized. And then highly publicized is a really, really small portion of attacks. Those are attacks that people are faced with making public because it is impossible for the public not to know about them. Like, your gas station not having gas, or your power not turning on in the Ukraine. The pipeline attack was not a rifle shot attack. It was the opposite. It was a shotgun attack on the industry. And, whoever the victim was happened to be the one that had to make the attack public because you were not going to be able to pump gas in the gas station. But we know many other victims of the exact same attack that didn't have to go through that public scrutiny as the pipeline that we're talking about.
Okay.
So that was a good point, and I think it's also important to mention here due diligence, and the legal consequences will probably happen depending on how negligent the victim is, and of course we need to follow due diligence to secure ourselves.
Another thing, I'm going to move on from this point. Another aspect of this that is new, and I think impacts both IT and OT, is the concern about the software supply chain that has really been accentuated in the last year. My experience with software supply chain is, working with service people on ICS who make sure that we had the exact right software to apply. But now it seems more like we're peeling an onion as we look through different layers of software. And in my experience, we've only had visibility to the outermost layer. That was the company that was supplying software, but those were simpler days. What are your thoughts about how end users especially should work to secure their software supply chain, and also suppliers? The supply chain is way more complex. How are we going to address that now, instead of just saying, well, I got this software from this ICS supplier, I trust him?
So who do you want to start on that?
No. Yeah. This is an ugly question.
I mean, I think that one of the things I've seen that has sort of impressed me is in the open source world, where people have actually realized that this is a problem, and they said, okay, let's build tools for this so that you can see not just, oh, I'm running this application, but it's actually running using this middleware, using this operating system, using these device drivers. I can actually see through the whole thing, right? And making that easier so you can actually, because these tools are actually also open source, it actually makes open source communities, it makes it a bit easier, right? Easier to get visibility, as opposed to if you, in the good old days, had asked Microsoft, where does all of your software come from? Well, we wrote it all ourselves, right? But that's clearly not the case anymore. But because of that, yeah, you need those tools, but you need to apply them even when some parts of the software is actually proprietary. So I think that's a piece that's helping.
Let me follow up on that. In terms of open source versus closed source, obviously there's a lot of legacy running on the edge, as people have talked about in previous sessions and so forth. Are those tools capable of showing or giving visibility at least to some parts of the activity of legacy and other kinds of things that won't be constructed out of open source? Or how do they interact with legacy? Can you comment on that, Erik?
No, I haven't seen them in practice how they work, but the sort of notion that, well, if I have some, embedded system built using Linux, right? Well, I think that you can actually use it to look at those Linux open source pieces. But then, how easy is it to deploy and use the tool? Does it assume that it can actually get, some of these things operate on the internet, and you point them at open source repositories and say, start with this project and basically traverse the transitive closure of all of the software components that it depends upon, right? Well, you can only do that if the software is actually published on the internet, so you can actually go through the source code.
Mm-hmm. Okay. Maria, I don't know if everybody else is. I'm having a little trouble hearing you. You're breaking up a little bit. I think Edgard is having trouble hearing you too. So I don't know if you can move closer to the mic or something. I'm not sure what the problem is there.
Or if it doesn't get better, maybe turning off the video if it's actually a bandwidth issue, but.
That's a suggestion. You're not coming through as distinguishable, so we can't understand your question or comment. I'm sorry, Maria. Edgar, did you want to jump in on that topic?
No, I agree with Erik. I think open source makes that a little easier, actually much easier. What I would say is that many of the tasks that we talk about are not achievable necessarily by a single operator. They require some leverage, whether it is industry-wide organizations or the work done by maybe larger operators like the federal government. I think I do think this is an important matter, and it's going to continue to increase over time. I think companies, vendors that have good operations, has in terms of checking what ingredients get added to their solutions. There are a lot of third-party tests, a lot of third-party hardening that you can do and show your customers, and we need to keep getting better at that.
Okay, well, let's move, Edgard, and I'll ask you to follow up on this in terms of best practices, and especially for defense in depth. Maybe you could just, talk a little bit about the best practices for defense in depth, and maybe give a definition of it, if you will. I think people know, but not everybody here is probably a security expert. So how would you define it, and what would you think are the key best practices for an end user to adopt?
Well, there are some of the bare minimum basics, right? And I think they fall in the concept of what kind of basic hygiene. Hopefully everybody, before they came to this session, they showered, brushed their teeth, did the basic hygiene. Well, very similarly, securing a perimeter, whether, like I said, I'm not going to use the word air gapping anymore because I don't think that exists in reality. But having a secure perimeter is important. Having proper segmentation done initially and audited over time is important. Having anything that looks like a PC or has a standard operating system secure with endpoint security is important. Having ongoing training is important, and having a fresh inventory of assets and the vulnerability status is important. I think when it comes to moving to basics to best practice, like I said, I'm a fan of what has been discussed somewhat in the 100-day sprint proposed by the administration. It requires ongoing real-time monitoring, which is, as we've discussed earlier, is very different in the world of IT, which tends to be very active and intrusive, versus the world of OT, in which it requires a foundational, a passive foundation. And a Tower of Babel, if you will, when it comes to all the different industrial protocols. I think Maria talked a little bit about a process awareness, which is key. A firewall in IT doesn't really need to know what you're doing to implement its rules. But in the world of OT, where you have a physical process running, if you're going to do anything in that network, you need to absolutely know what's happening, and to understand what's allowed versus not allowed. So best practices really have to do, especially when it comes to OT, whether it's edge or not, with OT-oriented tools that provide real-time visibility, real-time monitoring, real-time intrusion detection, to try to bring OT to the same level of cybersecurity that the IT systems have with specialized solutions.
One observation I would make is just where it's possible to virtualize, and I know a lot of legacy can't. This is very difficult, but I've seen new products where people have used virtualized networks in critical applications like software-defined networks, really, in electrical substations, and it would seem that virtualization would be a good way to get increased monitoring for legacy systems. In the earlier session, people were talking about, well, 90% of the legacy we see around the edge is Windows XP or even older sometimes. So that might be a way, although it's certainly not a silver bullet.
One of the reasons, Harry, that we're so excited about our partnership with ZEDEDA is that ability, right? We one of the rules that you'll find about modern humans is that a few thousand feet from where any one of us is, there is an electric substation delivering power to us. There is a water substation delivering electricity and now water. There is a gas substation delivering you gas. And historically, there's been zero data center capability, therefore zero virtualization capability in the distributed edge. And the distributed edge is absolutely everywhere there are humans, which is everywhere in the world. It's an incredible opportunity from a market perspective, and I think ZEDEDA is bringing something that can really penetrate bring virtualization to the edge, so that we can move forward from legacy faster.
Yeah, and I think that sort of, how can you actually do that securely, right? These systems that, whether they're running old versions of Windows or some other, embedded systems, right? How can you actually connect them where you could at least extract data out? In many cases, the sort of initial applications might be less about control, but more about, okay, how can I do predictive maintenance, right? By extracting some data. Well, being able to build that, using virtualization to be able to build that one-way pipe out, where you can actually export that stuff out, get it to the cloud. Someone can run the higher level analytics over there saying, okay, we need to send someone out to replace these components or whatever, right? I think that's an important stepping stone, but I think that you also need to, I think what Edgar touched upon, saying, well, key of this is actually being able to observe what's going on. You can have defense in depth, but if you're not looking, did anybody get through the first door, right? If no one is paying attention, well, they can just keep on working inside that door to get through the next door, right? So that I think doing that sort of real time, right? This is clearly something that we need to get better at, particularly when these are cyber physical systems, because they can then get at some point in time, after getting through some number of layers, to get to the thing that can turn on and off that valve or whatever it is, right, in the physical plant. So.
Let's move on. I think a related question has to do with usability, and Maria kind of touched on that in terms of at the beginning, in terms of having different priorities. But usability is certainly a question. Generally speaking, I find that the OT folks, the operational people, think that usability means I never have to touch it. And in terms of their OT systems, that's kind of how they look at it. How do we do that for security tools in the OT space and in the industrial control system space? I don't know who wants to jump in on this. I know, Edgard, your company does a lot of visibility for these kind of systems that in the past have been opaque or not really any kind of visualization. Who do you find using that kind of capability, and what are the other things that will help the monitoring of OT systems in a usable fashion?
I think let me start and I'll try to be provocative. I think the days of set it and forget it are gone. I think we have, especially in the distributed edge, we have service providers, servicing our substations all the time. And nowadays, in today's world, it's just not acceptable that we don't know what they're doing. We can't even detect when they showed up. We don't know when they left. We don't know what they did. The set it and forget it world is just unacceptable today. So, if something happened in an IT network in a regular company, you tend to know when assets join the network, when assets leave the network. You can monitor what they did. You can ask them questions. What type of software are you running, and you can detect the language that they're speaking and whether they're saying bad words in the conversation. But you can't do any of that in the world of OT. And like I said, we need to bring the legacy stances of set it and forget it or air gapped to the reality of today, which is not bad. And I agree with your point. I think you have to add value beyond security to be more digestible, more usable. So real-time monitoring does not just provide cybersecurity benefits, right? We do replace in many of our implementations, people going in trucks with Excel sheets up to reservoirs to do silly things that should have been done over the network. So we call that operational visibility, which has cybersecurity aspects, but also operational optimization aspects. Being able to monitor your network in real time and having a real-time map of your network is something that people want to have and want to do. And then more importantly, one of the concepts embedded in the digital transformation terminology has to do with doing more with the data. And OT data has been captive inside of an OT network for way too long. And being able to apply analytics in the cloud or not is something that both ZEDEDA and ourselves are very interested in. Freeing data from their OT jails, it's something that adds tremendous amount of value for a lot of operators.
Well, that's a little provocative, but I think that 2 points that were raised earlier, Erik raised the point about the differences between IT and OT in terms of the resources and the ability to interrogate and disturb systems that are in operation. And Maria talked about the different priorities that are kind of there. I think that maybe that priority, both those factors seem to contribute to a need for, I would say almost a heightened need for usability in the OT space than we would find in the IT space. Although I'm so inexperienced in the IT space, I dare not say that. But you have a different user community in the OT space, even when you're working with folks who are more IT savvy than most of the OT population, and different priority as Maria mentioned. So to me, it seems like that's a barrier and a important consideration for products and deployments there. Does anybody else want to jump in on that? I'm glad to see you back, Maria. I wonder if you have any comments on usability and how you do that.
Yeah, can you hear me now, though?
We can hear you. Yeah.
Awesome, great. Yeah, so Edgar was indeed provocative, but from the oil and gas point of view, for example, we have a lot of scenarios where connectivity is just not as available or very expensive for low bandwidth. So actually, we do want to get to the point where we can send all of this data and analyze it, in the clouds and have the dashboards monitor it. And our priorities should be to integrate it with our security monitor and operations center. But, we have to work on a lot of customization sometimes at the edge to get the right information, maybe use AI, some kind of machine learning so that we know what's the good posture of the devices, what's the, unusual accidents. So we only send the necessary data because, to be fair, connectivity is still one of the challenges, especially for industrial IT scenarios. So we can't just send everything to the edge. And that's one of the, unique challenges with this edge cybersecurity for us.
Yes, and your installations are usually determined by the location by geologists, and it's like not anything else.
Yeah. I wanted to give a quick comment on this binary. The application analysis that I kind of try to chime in to. So there's actually some vendors, and that's something we did in Sleek, is evaluating some vendors that could help us analyze third-party applications. And there are some vendors out there, not very many, but they can actually take binaries in, and not just, like simple languages like Python, but actually like C and C# and try to reverse engineer them automatically and tell you, okay, here's the potential issues with this application. And there's also another approach when vendors use when they run it in a container environment, in a sandbox, and learn about runtime activities. So there's certain tools there, although not open source, as we mentioned already. They're not open source. They might cost some, but they're able to do or de-risk some of your operations for sure.
Okay, I think we're completely out of time. That it's actually past time, and I'm afraid that somebody's gonna bump in and tell us we're done. So before that happens, I would just like to say thank you to all of you for your contribution and for being here, and thank you to ZEDEDA for making this discussion possible.